Alright, so this is our final sequence of, this is the final video before we start actually learning how to code up the tree, which is actually fairly straightforward. Again, because we're going to be using the algorithms, the zigzag algorithm all the time. So here is the tree traversal algorithm. So a tree traversal is just simply a way you go through all the nodes in a tree. This seems like this is important, like if you want to like print out all the nodes or all the data stored in the tree. Okay, so there's, however, a lot of different ways to walk through a tree. So there's three different types of traversals: in order, pre-order, and post-order. And they just describe different ways of walking through the tree because that gives us different kind of relationships between the nodes. Fortunately, they are all the same algorithm. The only difference is what the order we execute lines are in. In order, so see, here's all this algorithm for all of them, and it's recursive, as you may have noticed. So base case: if the tree is empty, return. Right? If your root is null, return. That's the true for all of these. Otherwise, visit the root. For pre-order is the first line. Then pre-order the left, pre-order the right. Visit or handle or process the root. For post-order, you post-order the left, post-order the right, post-order your root. And in order, you traverse your left, process your root, and then do your right subtree. So notice that these are all the same. So how does that kind of work here? So I happen to have created a diagram in advance. So let me go ahead and take advantage of that. So tree. So here we have a binary search tree already created for us. So let's go ahead and see what order we would do things in if we were to do a pre-order traversal. So suppose, so what we're going to do is to represent visiting something, we'll print it out first. We'll visit something by printing it out. So let's go ahead and create a text editor. So to represent visiting it, we'll print it out first. So the way pre-order works, again, is that we visit the root, then we visit our left subtree, then we pre-order our right subtree. Visit the root, pre-order left subtree, pre-order right subtree. Okay, so this root, we start at 7, right? So we visit the root first, then we pre-order the left, and then we pre-order the right. So the left subtree is 2. So then we just apply the same algorithm. So we process the root, then we pre-order the left, then we pre-order the right. So we go to our left first, 1. Okay, so we processed our right? That's what the algorithm says. Visit the root, or process the root, traverse the left, traverse the right. So we're here now. So we did 2. We were at 2. We said to process 2. Then we processed 1 because that was 2's left. Then we processed 2's right, which is 3. Okay, and so now so 3 then will then say pre-order my left, which is null, which says to do nothing. Pre-order my right, which is null, so do nothing there. So 2 says, oh, I've done both my children, and 7 goes, oh, great, I've done my left child. I've pre-order traversed my left child. Now I'll pre-order traverse my right child. Okay, so process 9. Then we pre-order our left, which means to process 8. Then we pre-order our right, which means to process 10. So we did 7, 2, 1, 3, 9, 8, 10, right? So essentially we essentially visit the root, then the left, then the root, then the root. So we essentially went like this. Okay. Next is the in-order traversal, which says to in-order traverse a tree starting at here. First, we traverse our left subtree, then we process the root, then we traverse our right subtree. So then so the first thing we're going to do is we have to in-order traverse our left subtree. Okay, so now we're here, and the algorithm says the first thing we have to do is traverse our left subtree, right? traverse the left subtree. So now we traverse our left subtree. So now we're here. It says to traverse our left subtree. That's null, so we're done. Process the root. Then traverse the right subtree, which is null, so we're done there. Okay, so I'm done processing my left subtree. 2 says I'm done processing my left subtree, so now I'm going to process myself. Then I'm going to traverse my right subtree. And 3 says I will traverse my left subtree, process myself, traverse my right subtree, which is null. I'm done. So 7 says, oh, I've done with my left subtree. And as you may notice, the numbers are actually appearing in like the numeric order that you would care about. So, and then we go to 9, which says to traverse my left subtree, which is 8, which says to traverse my left subtree, which doesn't have anything, which says to so then I process 8, traverse my right subtree, which is nothing. So then we go back and traverse 9, process 9, then we traverse 9's right subtree, which brings us to 10. So all numbers then appear in order. So it's kind of aptly named, right? And all we did was switch what occurs at which line. And the slides go through a analysis of this, or they have some different metaphors for this. If you want to follow your slides, their slides starting at 48. But I find it pretty direct to do. So Postorder says, before I process myself, I have to traverse my left subtree and then my right subtree. So if we start here, I traverse my left subtree, which is 2, and 2 says, well, before I process myself, I have to do my left subtree and my right subtree. So I'll do 1, which says I'll do my left, then my right subtree, then myself. 2 says, okay, I've done my left, now I've got to do my right. 3 says, left and right don't exist, so I'm going to do myself. And then 2 says, I've done everything, so I'm going to handle. So now I'm done with myself. So now we go up to 7. 7 says, okay, great, my left is done. Now I got to do my right. 9 says, got to do my left and my right. So we do 9's left and then 9's right. We're back at 9. And then finally at 7 says, great, I've done my left subtree, my right subtree, and so now we're done. So that's the way you do those. Interestingly enough, so of all those, the Inorder Traversal is probably going to be the one we use the most. But if we look back at those expression trees that we mentioned earlier in the chapter, right, we can break down this expression x plus y times a plus b minus c, right? And if we do an Inorder Traversal, we will get this sequence, right? Which would be the infix form of this. And then we would have to put in the parentheses that were needed ourselves, but we can do that. Interestingly enough, though, if we do a post-order traversal of this tree, we will get post-order or postfix notation, which we've learned about when we do stacks. And if we do a pre-order, amazingly, we get a prefix notation, right? And both of those don't need parentheses because, again, they're unambiguous. That's pretty cool.